Okay, so let's go over. This is the stuff you guys are having a lot of trouble with. Let's go over it again. So L stands for linear, E exponential, P power, Q quadratic. Linear functions have an add pattern. Exponential have an add-multiply pattern. Power functions have a multiply pattern, and quadratic functions have a constant second difference. Totally different. So let's talk about that one first, and then we'll come back to these 4 examples. Polynomial functions. Well, a type of polynomial function, subcategory, linear. That's the most basic polynomial function, sometimes known as a first degree function because it is to the power of 1. They never write the 1. You know this. A second degree polynomial function is also called a quadratic function. Second degree, it has a power of 2. First degree, power of 1. Third degree is sometimes called cubic functions. Actually, it's always called cubic. It's rarely called third degree. But third degree, exponent of 3, blah, blah, blah. First degree functions have a constant first difference, meaning if I find the difference of these numbers, it's going to be the same. Constant. The same. Interesting how sometimes math and real life come together. That's what constant means in real life, and that's what it means in this situation as well. So a constant first difference means when I take the difference of these numbers, it should be the same. 8 to 12, it went up by 4. 12 to 16, it went up by 4. 16 to 20, it went up by 4. Notice? It has a constant first difference. You never ever have to write, pretend I can spell. Constant first difference. You never ever have to use these words to explain linear functions. For linear functions, all we need you to say is, increasing by 1, increasing by 4. Or plus 1, plus 4. That's all we need you to say. If you want to get all fancy and write that, I guess I'll count it. Yeah? It actually shows a little bit higher understanding, in my opinion. Quadratic functions have a constant second difference. This time I'm going to spell it correctly. Learn from your mistakes. Constant second difference. Okay, that means if you take the difference of these, let's see, went up 14 here, we went up, math, 18 here, we went up, geez, oh gosh, so much pressure, 14 plus another 8, 22, 22, zeros, I love zeros in math, makes life so much easier. Let's see, 7, 26, okay. Now if we take the difference of those differences, that'll be the second time we take the differences. Yeah? That's why it's called second difference. Went up 4. Went up 4. Hey, look at that. Went up 4. By the way, that's just a coincidence. I don't want you to think it's always going to be 4. That was just random because I'm stupid and didn't try harder to make better problems. As long as this number is the same, that means it. Constant means the same. Yeah? Cubic functions. Not that we're doing cubic functions, but I figured you ought to know. Oh, heck. Busting out the calculator. Why? Because look at those numbers. I mean, I can do math in my head, but not like that. Watch what I do to figure out what it's adding by. I know it's going up. I know it's adding. So I'm going to do the opposite of adding to figure it out. That's what you do. You went up 34. And then 113 minus 43. 113 minus 43. You went up 70. When 231 minus, yeah, definitely can't do this math in my head, not fast at least. You went up 118. 231, 409. 409 minus 231. You went up 178. By the way, each of the tables that I have shown you, it has one too many points, meaning more than I need. One more point than I actually need to establish a pattern. But I like to call it better safe than sorry. Minus 409. 250. Oh shoot, I should have known that without a calculator. Yeah, whatever. So that's called the first difference. Now we're going to do the second difference. And I probably won't need a calculator for this. Okay, maybe I will. 26? Oh gosh. So nervous. So what do you do when you're not sure? You check it on the calculator. Hey, see? That's why. That is exactly why you check it on the calculator. 118. Now I ain't playing around no more. Shoot. 38. And oh, I could do this without a calculator. 60. Went up by 60. And shoot. Nope, calculator time. 250 minus 178. Went up 72. This is called the second difference. Notice it's not the same, so it's not constant. But it will be plus 12, plus 12, plus 12. Constant third difference means it is cubic for sure. Voila. A fourth degree polynomial would have a constant fourth difference and so on. Alright. Look. Now we come back to this. Notice 4 problems. That's the order I'm going to check it in every single time. I'm going to check, is it linear, is it quadratic first, because it's just, that's the quickest thing to do. Now, one thing I want you to notice, the numbers are getting bigger. 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 When numbers get bigger, the pattern must be it's adding or it's multiplying. That's it. That's all it can be. Y'all making math way too difficult by not using your brain. Okay. Use your brain. So, I'm going to see if it's linear. It's real fast. What's the difference here? 2. What's the difference here? It went up 1.6. What's the difference here? It went up, oh shoot. It sucks when I can't do math fast. Shoot. 9 minus 7.6. 1.4. Went up 1.4. And then it went up, I can do this. I can do that with 1.3. Okay? So, the fact that these are not the same means automatically it is not linear. See how fast that was? Now, while I'm looking at the first differences, I might as well check. From 2 to 1.6, that went down by 0.4. From 1.6 to 1.4, it went down 0.2. Down 0.1. These are not the same. It is definitely not quadratic. Look at that. How fast that was. Now, I literally have a 50-50 chance of guessing correctly. But we ain't gonna guess. Yeah? Let me come back to this. Okay. So it's not adding by a constant amount. It must be multiplying by something. That's the only other option to make numbers get bigger. We already checked to see if it's adding by a certain amount. It's not. It must be multiplying. Period. End of story. No discussion. To see what it is multiplying by, you take the second number divided by the first number. Why are we dividing? Because the opposite of multiplying is dividing. It is multiplying by 1.5. No doubt. That's clear. First number is 4. Enter. Multiply that by 1.5. Enter. Yeah, we got a 4, and then we got a 6. Oh, shoot. Oh, we got a 9. 4, 6, 9. 4, 6, 9. Notice it jumped this point. When that happens, cross it off. Don't look at it anymore so you can establish the pattern. And then what's the next one? 13.5. So it skipped 10.3, went to 13.5. By the way, went 99.9% of the time, if you need to do this, if it skips, it's almost always going to be polynomial or power function. Okay, just to prove it, let's look at the pattern. From here to here, times 1.5. Oops. From 6 to 9, that's times 1.5. From 9 to 13.5, that's times 1.5. From 2 to 4, that is times 2. Power functions have a multiply pattern. From 4 to 8, multiply by 2. From 8 to, this must be 16. So the pattern for this particular function, times 2 times 1.5. Okay, next one. You know what I know it's not? I know it's not power. You know why? Because there's only 4 types of functions and we just did a power function. See how logical that is? I haven't even done any math, but I know it's one of these 3. Again, y'all, for some reason, the last couple weeks have not been using your brain. I don't know what's going on. I really don't. All right, I'm gonna do it in this order because that's what I told you to do. Dun, dun, dun. I'm gonna check to see if it's linear. What's the difference? I already did this. It went up 2. It went up 3. It went up 4.5. It went up. I don't know. You don't know. Use a calculator. 20.25 minus 15.5, 6.75. Bam. Notice how these are not the same. It is not linear. That fast. Within a matter of seconds. You know it's not power. It's not linear. 50-50 chance. Okay. But since I already have these differences, I'm going to do the next level of differences. It went up 1 here. It went up 1.5 there. Look at that. It's not the same. It went up, $2.25. 2.25. Because it's not the same. It's not quite just like that. It is exponential. Dun, dun, dun. The numbers are getting bigger. Numbers only get bigger if you're adding or multiplying. We already saw that it's not adding by the same amount, so it must be multiplying by something. Has to be. That's the only logical explanation. So what is it multiplying by? Let's pretend we didn't just see these numbers. You take the second number, divide it by the first number. Why are we dividing? Because we know it's multiplying by something. We have to divide to figure out what that something is. 1.5. It's like solving an equation, basically. Working backwards. So it is 100% guaranteed it is multiplying by 1.5. No doubt. 4. Enter. Times 1.5. I bet you $100 billion it's going to say 6. And I bet you $100 billion it's going to say 9. I bet you $100 billion it's going to say 13.5. I bet you $100 billion it's going to say 20.25. Multiply by 1.5. Multiply by 1.5. Multiply by 1.5. This time it didn't skip anything. We didn't need to ignore any data points. So it literally is going 2, 4, 6, 8, 10. I asked you that on the first day of the lesson. And this is what really made this whole last 2 weeks go south. I said, what's the pattern? And you guys just sat there. Didn't even try to explain what the pattern was. It is clearly adding 2. How hard is that? We sat there for at least 10 minutes. Is that my fault that you guys are not trying, or is that your fault? Yeah, I'm a little bit cranky. Sorry about that. So it is exponential. Exponential functions have an add, multiply pattern. Add, multiply pattern. Okay. I know for 100% certainty, because this is how math teachers think, if we covered 4 types of functions and there's 4 problems, we know it's not power, we know it's not exponential, because we did those. So this, right off the bat, I know it has to be linear or quadratic. I haven't done any math, just logic. Okay. Let's check for linear. If it's linear, it's going up by the same amount. Clearly it's not, but I'm still going to check. Went up by 10 here, it went up by 14 here. Automatically I know it's not linear, because it's not the same amount each time. Let's see, 22 and 28. But because I know it's quadratic, I'm still going to verify that it has a constant second difference. Adding 4. Mother dookie, what did I do wrong? 2 to 12 is 10. 12 to 28, 16. Shoot. So that's a 6. That's a 6. That's a 6. No! Whoa. I don't like this problem. So it has a constant second difference of 6. This is the evidence. So it's not good enough to just say it's quadratic. You have to tell me why it's quadratic. So it is quadratic because it has a constant second difference of 6. Those of you that are into conspiracy theories, there's Q, not a good letter nowadays, if you've been following the news. And 666, definitely not a good number. Quadratic. Watch this. This one's linear. I haven't even done any math, didn't even look at the numbers. You know how I know it's linear? Because it has to be by process of elimination. But let's verify. You do have to describe what the pattern is. So we got to figure out what it is, in fact, adding by. Numbers are getting bigger. That means it's adding by something or multiplying by something. But we already know it's linear. What is it adding by? Take the second number, subtract it from the first number. Subtract the first number. Oh, words matter. It is increasing by 3.9. 3.9. Every time. Plus 3.9, plus 3.9, plus 3.9. So the pattern is adding by 2 here, adding by 3.9 there. Adding is linear. That's it. That's the entire lesson. From 2 weeks ago. Actually, it was last Monday, but Monday didn't go well, and then the Thursday after that didn't go well. Today didn't go well. It went better, but yeah. Part of that, I would absolutely take the blame for that. But part of it, when I ask you 2, 4, 6, 8, 10, what's happening to the x values? What's the pattern? And you just sit there for 10 minutes without saying anything. You have to take some of the blame for how the lesson goes as well. Oh, why did it not stop?